Hello, and appreciating that people are still coming. So thank you for your time. I hope you enjoyed your lunch. You don't feel sleep, as I am doing now, actually. I tried to get some intense coffee, but I found the grinded coffee and with beans, so it was a really good one. Thank you for joining my talk, and I hope that you enjoyed the previous talks. It was given by amazing speakers. And actually, the first keynote speech, I'm going to build above it because it's the same concept, but when it comes to design and architecture, I'm not going to target any language. We just need to understand the process of designing and how to make this design RESTful API, not just some resources and URLs and payloads, so we are designing REST API. We also might understand the difference when we use what, because based on my consultation, and the story behind why I get this talk, it's based on the consultation I do, code review the design, and also when you are starting different kind of project, how can I approach my project? How can I add services? What is the best way to get resources? How can I complete my story? And then I have a contract that I can give it to front-end engineer, mobile, wherever anyone can consume my APIs to get the service. And in isolation, I'm working on the back-end side, despite the language that you use. So my name is Mohamed Taman, and I'm truly pleased to be here in Portugal for first time. And it's an amazing city, amazing place. Thank you for the organizers to have me. So I'm working as a solutions architect or enterprise architect, but my area, my focus domain is Java. This is why we are Java champion. So I write a lot for Java magazine. This is how you can spot me, by the way, and just search my name and you will find everything. So you are welcome to ask me at any time, any questions, anything that you would like to have, or just follow because I write articles for Java magazine, as I told you about Java, so you'll find a lot of stuff. And also I write for IBM developers, InfoQ, and this is some publication that I had previously, but I'm focusing writing more. So let's get into our agenda today, what we're gonna have. Actually, we would like to have some tips how we can model our, the tips about the modeling. How could I have a process? The process will lead me to the correct design. So we will know about the tools, process, and everything, and also we have to know our participant in the system, like system analysis, but as a developer, how can I identify resources? How can I identify who will consume my functionality? This is very important in order to really design your API. We will see an example for this. And finally, did I miss something? How to go into iteration to validate that I don't miss any requirement. And I completely finalized my functionality. Then we have all of this kind of stuff laid out, but how can I now design and relate it to our HTTP protocol, because REST is HTTP protocol, but in the correct way. What is the minimum, bare minimum we would like to have in order to perfectly design our API? And then, now we have a REST API. It doesn't mean it's RESTful API. What does it mean by RESTful API? RESTful API has to consider all this kind of architecture pattern, how we can address it, and how can we, enrich our API to have this kind of versioning, security, caching, uniform resource. This is the most important and the hardest one. We will get into touch. So this is all about our agenda. So let's go. Are you ready? Let's deep dive. So there is always three approaches I found during building projects or contributing or consulting in adding an API to get something quickly to the market. But before I talk about this, let's talk about design, because API design is hard. And when I design anything, not just API, I have to ask myself these questions, like what functionality to express and how to expose it, and how the best way, which is the easiest way to expose. It doesn't have to be complex. And this is the hardest part. It's easy to develop a complex system, which is very hard for people or consumers to consume it. And when you get it simplified, it's the hardest process. And then to get This API, more simplification, you have to adjust and improve. Even after you just first release, second release, no matter what, I can improve at any time. So, as you know, there is always in computer science two hard things, naming and caching and validation. So, naming is most important thing in our computer engineering term, naming of the method, class, documentation, the resource API, the URL even. When I do proper naming as a consumer, I will expect what next? I will expect what's in the naming conventions that you are following. I don't have to read documentation, don't have to ask you more questions and all of this. But this is something, it has to have a process. And when you are working in design and computer-human interaction and this kind of UI and UX, you have something called affordance. Affordance is that you can do something and you accomplish something. This is like our functionality. Why I'm mentioning this, I will tell you some design examples. Let's take, for example, like the door locker. What is the affordance? When it comes to design of product, affordance of the door locker only to do one function, to open and close the door. Easy to hold, to grab by your different sizes of hands, and just turn it right or left to close, or open to close the door. That's it. It doesn't do any more functions. Same like the switch. We love coffee. Let's talk about coffee cups a little bit more, but affordance in practice, as I told you, what API allows you to do, and what APIs makes it easy for your customer to do the functionality it's supposed to be done, and what does the user want to accomplish actually. Don't do too much functionality. Don't engineer. So let's talk about coffee. Since we are all developers, we like coffee. So if we have a coffee cup to design, the most important part is I can design it without any kind of handles. But it will not be easy to hold it if it has hot content. So when I design something, could I accomplish more functionality? Yes. Handles are great because it's designed for holding when content is hot, easy for holding, and also can be used to hang it in more places. But this is for product, and it should apply the same concept in our API. Let's see how we can apply affordance and even the naming and the concept of design into our API. Let's get back for adding an API. So the first thing that we have something called bolt-on strategy. What does it mean? Do you know what is bolt-on strategies? It means that I have brownfield project. What is brownfield project? It's ongoing project. It's still modern, using latest technology, but it's already developed. And your CEO or customers like demanding, I need a mobile application, I need to integrate with some other third party, I need to provide my services for more. So I have normal web pages, I have normal, soup-based API, but I need some stuff getting done to expose it in order for many customers or clients to consume it. So I wouldn't like to add my API. This is called brownfield. What is the advantages here? It's a brute force approach. You already have functionality, you just want to expose it. And then this is the fastest way to get something useful done and takes advantage of the already in the code and system exists. But there is also some little bit problem we have to take care of is that bugs definitely could leak through the API. If you have bugs in the system, you just expose the functionality, you will have these bugs. So you have to take care to write specific test cases in order to make sure that the functionality is written in the right way. The best second approach and the most easy, but it has different mindset, is greenfield project. From the name, it's pretty easy that greenfield means I'm starting a new project. So I have nothing done already. So I start with API first or mobile first approach. I'm checking what the client really wants from me, and I design based on this. We will see an example of this. And this is easy. Take advantage of the new technologies, the team that you have, and you are building your stuff. You're sitting with all your teams like DevOps, testing, and front end and back end, seeing the functionality, and you are just grouping and design, and that's it. And not always the possible to drive business value. You have to have some mechanism, agility and lean methodologies, and to get just the bare minimum functionality to the customer. They test it, you review, you change accordingly, then you provide, because you need to just go to the market immediately. You cannot wait until you finish everything, then you expose it to your client. The third, which is we usually do if you are working for financial systems, banking, whatever this is, pension, as I was working, they are working with COBOL. So how can I expose COBOL to, there's tools that you can use, which we call it Facade, because these systems are already robust. It's like for a long time it's running, but is not, suitable for the modern API and consumption. Like I have a pension system and I won't like to expose it for mobile applications to make it easy for people to try to get their pension and all of these kind of things, or banking or whatever it is. We have it. Yeah, we would like to wrap existing functionality as we go, but the biggest problem here, and yeah, it's ideal for legacy system because it always function, but the problem here is the different mindset between you as an object-oriented modern architect or developers and the guys working on that systems like COBOL and everything. You have different point of views, so you have to take this into consideration. Once we identified which system we would like to expose based on bolt-on, brownfield, greenfield, or legacy system, we knew now what functionality we need to expose, who is going to use the system, and all of this. We need to model our system. How we can do this, let's see, because modeling is very important. But before I go further in the process, I would just like to lay out some rules. It's very important because I saw this, like a lot of developers stuck choosing specific tool, try to learn it hardly, like I'm using Draw.io, I would like, man, you can use paper and pen. Get the job done, it doesn't matter. So first, don't worry about the tool. Use what's comfortable to you. It doesn't matter what is it. Or based on your company offers, you can make use of it. Write it on a piece of paper, draw it out there. Write the functionality in your notepad, taking notes, record it, doesn't matter. Use what's comfortable to you. Second, have a consistent process. Don't try to distract yourself. Like, this guy told me something. No, even if you find a new rule or value, just add it into your process. At least you are going through process, and you just enhance this process to get your job more validated and more accurate. And finally, actually, it doesn't matter unless it's written down. Because we are, as a human, we tend to forget quickly. And this is normal. When you are in a session, I bet you, when you go out, you will forget about like 30 or 40% of the content, and this is natural. You will just remember the keywords, and this is what I would like to give you here. And you have a presentation to look over. Just our focus mechanism working like this. This is why we have to record or write it down, because when you get back to the second day, you will forget about the content. Then the next day you leave it, you forget more. Then when you write it, you will miss. Then you have to e-meeting again and get the content. So writing is very important. And document everything. And then you can deprioritize everything later on. So this is very important because I found these problems always when it comes with analysts, come developers. Yeah, I attended, I remember everything. Second day, half of the requirement has been missing. And then we develop less function. Then we go through all of this. I didn't say this product owner, fighting, and I mentioned this, and I have to give my time again. I'm like, okay, sorry. Do you allow me to record? Yes, thank you very much. Then I listen, and you have something proved. Okay, now we get the requirement. We would like to identify the basics. Who will use our system? It's like when you do UI and UX, you have persona about your system. Either it's system, person, another tool, whatever. List everyone and see, do you really interact with my system or not? This is very important. So this is a question you ask, like who they are, external, internal security, aspects you have to take into consideration, how they are going to interact, what is the kind of API you have to supposed to give it, because sometimes internal people are definitely more Some have some functional and security than the other people outside or systems. You have to take care of this. External or internal, and short description about them. And then you know your users. And then let's see a small example about coffee shop. So who are our participants in any coffee shop? You have the patron, which is you, going to ask for coffee. And you have cashier, barista, who's preparing, the coffee, and other customers. So those are usually. So how can I identify activities and breaking them into steps? Yeah, those are my participants. What they are going to do is my system. I say, okay, the activities here, you place an order. Yes, I would like to order coffee. You wait for an order and you receive an order. Is there something missing here? The others. Yeah, the others. So I'm describing only me. So, okay, who is going to prepare the order? So second revision, I could start like this, but when I review, I'm just describing the customer. Where is the cashier and barista that I identified? There is no interaction. I will do revision number 2, and they will say, okay, I have to mention the barista, patron, which is you, create an order with the cashier. This first interaction. The cashier passes the order to the barista. Makes sense? And then the barista acknowledges the order and adds it to the queue. I have a queue, this is something new, okay, nice. And as orders are processed, inventory and machines are tracked. This is something new, has been discovered during, the interaction. And then orders are ready, they are announced and delivered for any customer who's ordered. So I have all the interactions between all my participants. Even if I found someone doesn't participate, but the activities it's valid, I don't need this anymore. But first, list all your participants. Reprioritize, document, shuffle. You did all the interaction, super. You don't need anything more. So you see, we started as a person, then this is the revalidation and process. I will do more and more if I found something is missing. And they will ask, is this really all what you want from the system? Yes, approved, then you can start developing. So let's see an order book and take it from participation, activities, develop the URIs and the verbs and everything. So this will be the complete example that we have. Our participant here, we will have it we have system admins that can maintain the system, interact, do something. We have developers, customers, and customer supports. This is not a complete book system, just small functionality. And our activities, I will not mention names, but you know the process. Our activities here, I need to place an order. I would like to look up an order. This could be done by customer support or customer, and place an order by customer, cancel an order, customer or customer support, add item to cart, remove item, clear cart, checkout. This is all the functionality that is required for me in this MVP phase. Okay, and I have the participant, everything's okay. How can I create and group the API method? Now I have the functionality and I have the resources. How they gonna interact? How can I develop? How can I reach the final URL that will do these activities on those resources? So we have to create and group the API methods. How we can do this? So before I deep dive, this is the process that I'm telling you about. You identify participant, identify their activities, then break it into smaller steps so you don't have more, because it should be only serving one entity at the time. Then create an API definition, and you go forward and backward until you finish everything. And finally, you have to validate your API. This is the complete process I follow always when I design, in a simple way. When you finish validating means I have nothing left. I covered all the participants and all the activities, and I'm ready to go for the next step. So just to remember, those are our participants, those are our activities, and let's now group, create an API definition. Yeah, we're going to technical part now. So identify the resources. This is very important. We have the resources always are nouns in your system. So the nouns, that activity acts upon them. So these are the resources. So I have an item, because in my activity list, I have item, add item, remove item, you know. So I would like to list all the items, view items, search about items, add and edit items. What else? I have the cart. I would like to add item to cart, remove item, clear cart, view, and check it out. Okay. The order itself, I would like to list order for customer, obtain order status, and cancel an order. This is nice. What else? I have customer itself, because I would like to view the customer from the perspective of customer support. Someone complaining, I have an orders note, what's your name? Search, I get your order. Then I will use the previous functionality. Search, add, edit customer. So those are all the activities based on our previous analysis, and those are the resources. Now it's nice. I know which functionality should be act upon resources, right? Let's do something. I usually use paper and pen or Jira and create a table like this. So to map activities to resource life cycle, because adding, deleting, it's a life cycle of a resource. I have to take discovered action into action and map it to HTTP, verbs. Our verbs in HTTP, which is those one, the most common, get, post, put, and delete. You have head, you have options, you have batch for many further activities, but those are always the base for us. Simply, we create a table like that. You have the resource above, you have the activity on the left side column, and you have verb, noun mapping. So if I would like to list items, get items, not item. This is a proper naming, so you expect it's agreed upon, it's not a standard. But since you are going to develop, because as you're gonna see, REST is not a standard. It's agreed upon principle and architectural pattern. It's not a soup-based design. You have to have a head, body, trailer, security in this way, and XML definition in this way. So it's completely different. And I go further. It's pretty clear because everything just functionality mapped to items. So you can end up with just one URL, changing verbs, and you expect all the functionality. So you have get items. Get. First one, it's pretty easy. Get all the items or nothing. The second one, I want the specific item from these items. The third one, I'm searching about item or items in those specific items. The last one, I would like to add item to those item collection. So it's always like that. And edit, I'm using put. If we talk about cart, it's completely different because you see adding item to cart. Should cart come first or item? Like how I can design this relationship. We will see. Remove item, we will leave it. Clear cart is pretty easy. Delete. View cart, because I'm talking about cart now. And then checkout. Checkout is not, it's a process. How we gonna design it. We will get back later to this. In order, I wanna explain to you something. For orders, we follow the same. Get orders by ID. Obtain order status, I can get it also by, I get the specific order, I will get the status, and cancel an order, I will use delete. So you see, you end up with one URL doing two functionalities for you based on what you have to take. And customer, there is no more, if you follow the same process, I'm expecting that you will have it. Search for customer, get customer ID, I would like to add customer and edit customer. So let's get back to see what relationship between resources. But in order to do this, let's understand the mapping of remaining activities that we talked about, which are those. So we have to understand the design relationship. All of you knows about the database relationship. So it's always resources, either independent, dependent, or associative relationship. So the same concept, So why? Because it's very important. I will clear it up with an example because we love to watch movies. And since we love to watch movies, I always ask myself this question in order to identify the relationship. Can the resource exist without one another? Does one resource only exist when the other exists? Or does the relationship between resources require more information than just a link between them. If you identify, you will know dependent, independent, or associative. Easily see this example, movies. You can see movies, the resource start at the beginning. You would like to get a specific movie. You would like to get all the actors who played this movie. And I would like to get all the characters has been played by those actors in that movie. And then I can get a specific character, and then I can get the actor ID. Yeah, he's independent. Doesn't matter which movie, he exists physically. And then I can get all the specific movie played by that actor, and I get all the characters has been played by that actor, and I can more specific. What do you think? What about the character? Character is dependent relationship. It doesn't appear at the beginning at all because it cannot exist without a movie or without an actor. But actor is independent relationship. So it can appears at the beginning as a resource itself. Like I can ask, what is your information? What is the movies that you played? Give me all your history characters, all your Grammy Award. This is how the relationship is. Any questions here? If that's clear, and sometimes both of them are independent, item and cart. So in this way, when we add an item, you would like to say, inside this cart with a specific ID, I would like to add an item to the collection of items inside this cart. This is how I would like to read it. Then you can also guess what is the next one. The same URL, but I'm changing the verb. So you end up with less and fewer URIs and URLs. You don't create bunch. Sometimes I found people like carts with ID, add item, then remove item. So you end up like with 4 different URIs, 4 items inside cart and different 4 carts, add cart, clear cart. No, you don't do this. Proper naming, and you will end up like one URL, changing verb, will do different functions. When it comes to checkout, it's a process. I want to do something. Payment, checkout will go to get the credit card information, post it to the payment system, notification system, inventory system, and then it populate all of this, like publish it to queue, and then you get this kind of like sending emails and and you have everything. So this is the process that we are designing. And for me, I have finished. With this, I can just write it in Jira or documentation or something, just missing some stuff which is the error codes and the acceptance code and all of this HTTP specific, but in concept of design and functionality, I can give it to the guys for front end. They start to develop the URI and start acting up and creating their JSON document, and they will know, because definitely I will give how the data look like. The most important part always is validation. So this is what we do actually for validation. We just make sure that we didn't miss anything. So if we would like to do challenge objective here, what if I would like to handle a missing order? And what if I'd like to reorder the same order? Cancel part of an order. New functionality. Does my API fit in this? Let's see quickly. Solution here is my order is missing. Okay. Customer service lists the customer orders. I have an API to do that. I don't need to develop anything new. Customer service obtain the customer order status. Then functionality done. I don't need to add anything. Another one, reorder. Customer view a previous. He can view their previous orders. We have such functionality, but customer cannot just make a copy order and do checkout. So I have to develop this API. Do checkout. I already have it. I don't need to develop it. And then part of my order is missing. Customer service lists the orders. I have an API, customer service view and active orders. I can get it because it's the same. Then customer service cancel specific. I have cancel order, but I don't have cancel item from that order. From order, not cart. It's completely different. So I have to develop this functionality. But you see, I just saw what my functionality does, and then I took it into consequence to finalize all what the requirement has been stated here. So this is how I revalidate. Finished, done. What is remaining is HTTP. Just I would like to give you an overview what is the important part of HTTP to think about. Yeah, it's not, as I told you, REST is not a standard. This is why REST is not a pretty URLs and not necessarily XML, JSON could be binary, it could be like whatever it is. And REST is generally agreed upon set of principles and constraints. Similar to SOUP versus REST is actually same like mortgages versus borrowing $10. Because if you want to buy a home, you have to go through a specific process in order to get the functionality done. If you don't do it in that order, you will not have it. But for REST, if I borrow you $10, you can give me 5. You can invite me for a dinner or coffee by other 5. It doesn't matter when, in which order, it doesn't matter. Finally, you will give me the $10 back. It's well understood, yes, but what is very important for the payload that we get and focus on are those headers and responses. The headers here is, I can definitely use many tools to sniff the headers. The content type, status, and media type. Those are the most important. And then you can act upon the response. How it's like, it's JSON, the media type, content type, how it look like as a structure, and the status is because error handling, and you know, these kind of messages that you're gonna describe to your customer. Responses, we have this. Definitely, you know that we usually work in these categories, but we don't use all of them. The most famous ones are for 200s, we use 200 for OK. This is the general agreed upon codes that anyone or reading your API expecting this. And you are using 204, not 404 for no content. It's completely different. Resource not exist is different than no content. Because I found this always people failing into this problem when they design. In 300s only you need this if you have maintenance or you are moving to new URI or new API or new version, if you have versioning and you would like to introduce the new version for your customer. And for 400s, you have those. 404 not found because you are calling wrong API, it doesn't exist already. You don't have this resource. For security purpose, 401 and 403, and if you have bad request, mean the structure of the payload is wrong, or the request is wrong, or you are calling an API with different verb, which is not supported. So those are all bad requests. 500s are general, you know, for back-end problems, and you have to map it correctly. Response code are great, but please don't create your own. Do not confuse unless you really need it and you have to document it to show to your customer. Same like exceptions. Try to rely on the GDK exceptions or your platform exception. And if you need business, you have to document why you are throwing that exception for more meaningful purpose for your customer or your developers. Now you have everything, and definitely I'm not going to show you the payload. The payload is your structure and agreed upon, you know, return data type for your client. Until here, you have a REST API. But in order to have RESTful API, I have to consider all these 6 constraints, okay? Any questions until now? Because those are the most important. Clear, thank you. Are you sleepy or just focusing? Okay. REST constraints here, we would like to talk, how can I make my API or application or backend service or whatever it is, like client server, architecture, stateless, it's very important. And we will see why, how it could be cacheable. This is for performance, definitely. And also layered system, how can I make it layered? So my application can have add-ons on the go. And code in demand, yeah, it's nightmare. It's optional one, but you will see that big tech companies are doing that. And finally, the most important and hardest one to keep track of is just uniform interface. Let's deep dive into each one of these. So client server means we have faced this every day. Web browser and web server. They doesn't know. I'm calling by the name of the server, and then it will resolve DNS, resolve the IP and everything, and then just don't rely on specific information like IP address. And this is very problematic. Always try to ask the DevOps guy to give a DNS name, then your guys from front end or something. So when you change services, it doesn't have to change. Even when you would like to connect to a database, try to ask for a naming for the server, not IB. This is very important to improve your testing and continuity of your service. By separating the two, we can vary. I can move to different server, doesn't matter, you're calling name. If I have something down, I have a cluster, another one come into play, I'm calling you by name. So you are not relying on me. Server, also scalability, definitely, and reliability. You are a continuous system. And I saw this literally big, like companies you go, like we have failure, because you're always using IB and you are just lazy to have a names in DNS properly and to map it. Just take this IB, let's finish it. Then you're crying and you're cutting your hair because you have downs, definitely. Stateless is very important because each request stands in its own. Do you remember when we tried to order the API calls to fulfill our requirement? Then we find a missing one, this is why it should be stateless. Request can be processed in any order, and it should be. And because sometimes they will, and this also serving scalability and creating more instances from your service, without relying on the session or information about the user or anything. Unless you really need it, but you keep it, this is outside cache, not inside your service by any mean. So can you imagine something like this? So this is why we use JWT token, for example, for communication. We don't use request response session-based security as like username and password, and you have information in your session you're relying on. We use in this kind of communication to keep stateless JWT or OpenID or whatever it's communication that I can submit for you the token at every time, and then you can identify me at any time. Yeah, we have expiration, this kind, but I don't have to log in. I log in once to get the token and I submit it at any time. This is Twilio API, by the way. It's pretty amazing. You can see here, they are using some like from to, and then they are using, the authorization token. And that's it. So talk to me at any time, in any order. I just need the token to identify you, and that's it. I will give you the functionality. Why stateless? More flexible, stability, and reliability, indeed. Let's move to caching. We have bunch caching. You can use Redis, you can use Hazelcast, you can use, but the simplest, easiest cache, you can find a GitHub using this, e-tags. The easiest and simplest one and understood by all the browsers by default. So caching API for each message should be described whether it's cacheable or not. And this definitely improves the network and application usage because you have, since we are in cloud environment and era, sometimes your service is going to be paid by API request. So you have to prevent this as much as you can. Make the system more reliable and scalable, yes, because you can scale and you can have more instance, because if whenever you hit, you have this request from API, so the hit is lower and lower in your backend systems. We have different kind of caches, and not just API. API is part. You have database, you have network, you have content cache. There is everywhere you can put a cache. But for API, it's much easier for browser to have these kind of messages if I'm serving the same response every time. Why have to hit the backend? So get, put, and delete should be idempotent, save. Whatever I do it once, so I have the request cached. Why I have to go to hit the backend to return that this search does not have any content in the back? So I'm caching all of this. The most dangerous one is post. Post is not, because post always changing the state of the resource. So you cannot cache it. You have to return the new response always. Because, for example, delete. Why idempotent? In my design, once I perform delete, either it's asynchronous or synchronous, I send the message. When I perform delete on the same resource, okay, I already have the request. It's already deleted. Why I have to go to the database to perform delete, empty delete? Done, already done. You perform the same request multiple hundred times, you are welcome, but you will not touch my backend. It's only once. This is the idea of idempotent. E-tags are built for this, generated for individual request by default, by the way. And it's compared to see if anything has changed. Available also for head. Sometimes I need to check about the availability of resource, but I don't need the payload, the JSON body. So how can I do this? Git will return the JSON API body. No, I just need to know this order exists or not. So I need 200. I use head for this purpose. I don't use Git. Git just because head doesn't have response body, just only status code. So I'm just making sure that resources already exist. So I reduce the network usage. So you are using the verbs in order to have more functionality, but just also for optimizing your APIs and response. You can see if I'm curling api.github.com, you can find the specific date and you find this e-tag. It's auto-generated. You have it in Spring Boot. You have it in Node.js library. Just you include it. It will be automatically generating e-tags for each resource. So you don't need it. And it will be understood by all the browsers. The last three, layered system, code in demand, and uniform. Layered systems mean don't count on the client interacting directly with the server, so we use this on the web every day, yes. So it adds silent, invisible dependency. What does it mean? This will allow us, if we have layered system, allow in-between system to be add and remove. I can add security at any time, any filters at any time, customer doesn't know. There is no reliability, like I don't have to force my customer to send me a specific request in order to use security. I will add it, I will filter, I will add caching in the middle, I will add zipping mechanism in the middle. He doesn't know, doesn't matter. I'm just adding and removing without affecting the client and the server interaction. And this is allow load balancer, caching, logging, authorization to be added on the go and remove as you want. If you go to cache and demand, what does it mean? Actually, it's not exist in each and every API. It just, when you send back your response, sometimes you send back a new functionality and you need that code to be hosted in your customer. It's a security issue, but we have it every day in Google, Gmail, by the way. Then you have new buttons, but you don't install anything or you update, just they have the JavaScript content that will act on this in your machine installed. So a request does not just retrieve the resource, but also the code that acts upon it, definitely. And we don't have to know or understand the code, just how to run it, and allow for flexibility. It's a nightmare, security issues, but as I told you, we have it every day. Gmail does it, and many more. Finally, uniform interface. 4 things that you have to consider. Should be present in every API to be fully RESTful. It's most complex, but most powerful one at all. Identification of the request. I told you about this. Naming conventions. Naming things properly will make your customer happy and expect what you're gonna serve him next, or how the URL is going to be called and which proper code you are going to return for success, error, move, for versioning mechanism, security, everything. Manipulation of the resources means hate use. Not all the people understand, but this means manipulation through those interfaces. You have a Fiori API, very clear. We know what they use. This is Twilio API. 3 URLs doing everything. And this is the documentation. Git for calls, recordings, and SMSs. Post only for calls and SMSs. There is no edit for any calls and SMSs, and delete only for recording, and that's it. This is a functionality. And it's very easy and descriptive, and the URIs, and you're using account SSID to identify accounts, and that's it. Self-descriptive message, yes, each one has to have, if the resource is cacheable or not, how to process itself, and how to request the next resource. Sometimes we need to do this. What does it mean? It's using hypermedia as an engine of the application state, hate use. complex, but it's very powerful when you would like to add functionality on demand and you don't need your customer. They can use it or not use it, but you already presented. Small example, because this is the last. If I asking a bank about my account, the bank should return something like this. I have my account number, the currency, the balance, and yeah, if you use that link, you can withdraw, you can transfer, you can close. Then sometimes I might expect more links. I just want to refer it to a button and do the actions. So you're discovering functionality on the go. You can just give it to your customer. So this is very powerful. Not everyone understands it. Sometimes I have argue with like the CTO or something. No, it's why I have to provide this. Because your customer, you are serving many customers. You don't need to knock the door. Hey, I have this functionality. They will have it. They have the proper URL. You can change your URLs also whatever you want. You're not relying to someone to code it, hardly, but you have it. So it gives you flexibility that you're exposing your API, changing your API, versioning and everything. So this is just link it to your button or UI, and that's it. Whatever you change, you just refer to the link, the href, and that's it. So this is the mechanism that you have. See, this is GitHub URL. This is, if you use all of this, that's GitHub functionality has been given to you in a very short payload. In this way, if we take into consideration all of these 6 design principles for developing REST and the design process that we have, I guarantee for you that you will have a proper design and you can, give it from the first part, you can just leave this documentation and payload and everything for your front end, and you are working in your back end freely. They can mock their data using files, JSON or whatever it is. They can functionality continue. When you're coming to integration, it will be like 95% correct, 5% for maybe you developed something new, you have introduced, but you have Swagger already developed, you have documentation for this and expose it. So if we done this properly, all this process and the process that we have mentioned, definitely we reach the goal of this presentation, that you have a great RESTful API design. Thank you for your time, and thank you for listening. I would like to take one more picture for you. Great audience. Yes. I would like to take a picture with you guys before you leave. And while I'm taking a picture, there is always a question between GraphQL just, vanishing REST API. You don't use the REST API anymore. Don't listen to this advice by any means. Every single thing has a business case. Thank you. Thank you very much.